Okay, this is the hardware setup for demoing or testing the SerialNet capability. In fact, any capability of the Wi-Fi modules. And what you see here is basically the EVB, the evaluation board of the module itself. It's this one here. Any of Connect1's modules or EVBs will be able to work as long as they support SerialNet. Any of the G2 modules or the G3, like the Pico, should be able to work basically the same because they're compatible regarding the commands and the capabilities. So power is connected via this cable here that you should have received with the evaluation board. Connects up to the adapter, power adapter. And we have a serial cable connected to the serial port on the EVB. And then in my case here, I'm using a USB to serial adapter that is connected to the PC and basically takes a USB connection and makes it into a serial port. So that's what I'm using as a connection, and that's the things that you should have received with your evaluation board. So for the SerialNet demo, we're going to need two pieces of software that we're going to get from the internet. One is a terminal emulator, and the other is a port server that will run on the PC. And show you the location of those. And the first one is a port server called TerraTerm. You can see the address here, where to get it, and you can download it and install it. Shouldn't be a big problem. The other one is this is the place to get it. And you can download, it's called TCP/IP Builder, which is a port server utility, and install that also, and shouldn't have any problem installing that. And we'll get to these when we start doing the demo itself. Okay, so we're going to connect up the hardware to do the SerialNet demo. So we have the evaluation board, and that's right here with the module on top, connected up to the power. This is the power cable. All right, that's the USB side, and then we're connecting up the socket on the power, and the unit is powered up. This is on off. Next thing we'll do is we'll connect up the USB connection. So for that we have the USB to serial cable. Connect this to the PC, one of the serial ports. All right, got that. And that's connected through our serial cable. And this will go into the evaluation board right here. Okay, so that's all connected up. To see which port on the PC we have with the USB interface, we go to the PC here. We go over to the different things that are connected, and we see here, over here, a USB connection. Which we open it up, we see that it's a COM3, it's a USB to serial COM port, and we know it's connected as COM3. Okay, so now we're on COM3. Just to see that we're connected to the board, we'll open up the TerraTerm, which is the terminal software. Choose the serial connection. Select COM3 that we just saw that we connected to. All right, and that's connected. And the first thing we do is send an AT+I command, and we receive back IOK. Alright, means we're connected and we're talking to the board. Thank you. Okay, so we're setting up our Wi-Fi module now for SerialNet operation. To do that, we need to set it up for two settings. One is connecting it to the local access point so that it can connect to the network. And second is to put it into SerialNet mode and to send it the right commands in order to do that operation. And after that, we can stream characters between the serial port on the Wi-Fi module and the server or TCP socket on the server on the PC. Okay, so first thing we'll do is open up Terra Terminal and connect to the module. It's a serial connection. We're connecting to the Wi-Fi module. I'm connecting through COM3, which is a USB to serial interface. And I'll say OK. We'll set up our serial port for 115K baud rate. And let's just see that our board is active, AT+I, and we see that the board answers back IOK. Okay, so we're connected. So now setting it up as a Wi-Fi client, connecting it to a local access point. We go to page 43 on the technical presentation, and we'll be able to see how to connect up this to an access point. It's page 43, and this is Wi-Fi client operation. Okay, so we go back here, and we'll get that set up. So first thing, AT+I, FD, which is factory default, and then we'll do a soft reset with AT+I down. Okay, we're set. Next, we'll take a look at what access points we have in the area with RP20, and we can see that we have a few access points. We'll choose the first one in the list there, which is called TI, and we'll put that as our access point. So WLSI, which is the SSID of this AP, is TI. And we have AT+I, SCC, WSCC, which is the security. We'll put in 0, which is WPA. And the password, WLPP. All right, and now we entered that. It'll take a few seconds to encrypt the password and store it in its memory. And as soon as it comes back, we'll continue. And we're back with IOK, and now we're doing it AT+I down, which is a soft reset, and when it comes up, it should be connected to the access point. We'll do it a couple of times. Should be connected to the access point, and we should have received an IP address, and let's check that out. AT+I, IPA, and we have our IP address 172.22.04. Okay, so we're connected to the local access point, we got an IP address, and we're ready for the next step, which is setting up the SerialNet parameters. So to do that, we're going to go to page 56 in our technical presentation. As you can see, this is page 56, and this is the SerialNet parameters and the commands that you need to issue in order to set up the module in SerialNet mode. Okay, so let's go ahead and do that. All right, so next to the first command is at plus I HIF, which is choosing the UART interface, the host interface as UART. Next one is setting up the serial port, at plus I, SNSI, which are serial port parameters, and we'll set that up. N10. It's that, and the way we've set it up is for 115K baud, 8 bits per byte, no parity, 1 stop bit, and no flow control. Next is at plus I, S type, which is the socket type, whether it's going to be TCP or UDP. 0 is for TCP, so we'll put that in because we're using TCP. at plus I, MTTF equals 20, which is 20 milliseconds, which is the maximum inactivity timeout between the characters that we send. at plus I, LPRT, which is the listening port that we're opening up on the Wi-Fi module, and that's going to be 5001. Then we're setting up the remote socket, which we'll connect to on the PC. So HSRV, that's the remote port on the PC, and that's going to be the PC IP address, which is 172.22.070, and the port we're going to connect to is 3001. That's the same port that we'll use in the port server software that we'll work with in a minute. Okay, set that up. Next is basically put it into SerialNet mode, which is SNMD equal to, and right now we should be in SerialNet mode, streaming characters from the serial port connected to the Wi-Fi module over to the PC. Now let's open up the TCP port server on the PC and set that up. We have the local IP, which is the IP of the PC, 172.22.070. If you don't know the IP of your PC, you can always go to the command.com that Windows has and issue the IP config command, and you'll be able to see the IP address of your PC right over here, 172.22.070. Okay, so that's our IP. 3001 is our socket. We're going to go ahead and create that socket. And now to connect to the module, we put in the module's IP address, which is 172.22.004, and the socket, which is 5001. That's the way we set it up. We press connect, and we should be connecting. And as you can see, I'm pressing characters on the terminal here, and they're coming out on the TCP socket here. As you can see in the receive data, I can say hello. Okay, and I see the hello coming out here. How are you? And that comes out too. So that's one way. If we want to send over to the serial port on the Wi-Fi module, we can put in data here. Is how do you do? And we send that over. I press send, and I can see how do you do coming out here in the on the other side. So what we've shown is that by connecting a serial port to the Wi-Fi module, configuring it correctly, we can actually send data from a remote serial port through the Wi-Fi module to a remote PC with a socket that's open, TCP socket, and receive the data and, of course, send data back. Thank you.